right, so we're going to talk about some real-world examples of direct variation. We've talked a lot about direct variation, how it's a line that goes through the origin, it has a constant rate of change, and that k represents that constant variation. So let's look at some examples here. Refer to the information at the left, assuming that the age of a dog varies directly as its equivalent age in human years. What is the human year age of a dog that is 6 years old? So it's really important that it says right here that it varies directly, because since it tells me that, I know I can use this equation, y equals kx. Okay, so most pets age at a different rate than their human companions. For example, a 3-year-old dog is often considered to be 21 years in human. So it doesn't tell me necessarily the rate at which it changes, but it does give me these two little pieces of information here. It says that if a human is 3 years old, a dog is 21. So if I assume that the dog represents the y, well, we'll do y is the human, and x represents the dog, then I can plug those numbers in, because that means that x equals 3 and y equals 21. So I'm going to come over here to my equation, and y is 21 and x is 3, right? Now, to find k, I would have to get k by itself, and right here it's just being multiplied by the 3, so to undo that I would divide, and if I divide that side by 3, I have to divide this side by 3, so k equals 7. Now that looks like a great answer, but I believe it said to write an equation, didn't it? Yes, write an equation. So I got to come back to my y equals kx, and this time I'm going to put the 7 in for k. And that's my equation. So I could use this equation then. If I knew how old the dog was, or if I knew how old the human was, I could find the other one with this equation. All right. A grocery store sells oranges for $2. How much would it cost to buy 10 oranges? Okay, so I've got y equals kx again. I need to decide what my x and my y are. So this time, let's let x be the number of oranges, and we'll let y be the cost, okay? So I know that I am going to get 6 oranges for $2. So $2 is going to get me 6 oranges, right? So if I want to find k, then I have to divide both sides by the 6, and k is 1/3. Now that's k, but I need an equation to solve this. So y equals 1/3, whoops, not k, sorry, x. Now, it says, how much would it cost to buy 10 oranges? Well, oranges are represented by the x. So if I put 10 in there for x, then I can solve for y. And y equals $3.33. So there's quite a few steps to get there. I got to find my k, write my equation, and then I can use that equation to find what it is that they were looking for. So just having to remember that finding that k, using our information to find that rate of change or that constant of variation, is what helps us get our equation, and the equation is what we need to solve the question. All right. The Stanton family rented 3 DVDs for $10.47. The next weekend, they rented 5 DVDs for $17.45. What is the rental fee for the DVDs? Now, they actually gave us a little more information here than we need, because they're asking us what is the rental fee. So I really just want to find out what that rate of change is, or the k. So I'm going to use the 3 and the 1047. So y equals kx. I'm going to make X equal the number of DVDs, and Y is going to equal the cost. So cost is $10.47, and X is 3. In order to find what K is, I'm going to divide by 3 and divide by 3. And K is 349. Now I could use the other one to see if it works. Y equals KX. So if my cost is $17.45, K is $3.49, and X is 5. $17.45. If I multiply $3.49 times 5, I get $17.45. So it checks out that I do have the same rate of change or constant of variation for both of those. And it is $3.49, which is what the answer to the question was. What is the rental fee? Okay, that's it.